11.4 section using integration. I'll start with this equation. We discussed this one earlier, 4t square plus 5t. So when we want to find velocity, we differentiate displacement. So this is 19 square plus 4t, 8t plus 5. We found a velocity. V equal 19 square plus 80 plus 5. And when we want to find the acceleration, we differentiate this one, dv over dt. Then this is 18t plus 8. Now we have the displacement. Then we differentiate. And then v. Then when we differentiate v, we will get the acceleration. Now I have acceleration a equal 18t plus 8. Now if the acceleration is given, now here displacement given, we found the acceleration. Now acceleration is given, how are we going to get the velocity from here? Then we have to velocity mean we have to integrate the acceleration. This is the reverse process. Then when we know velocity, to get the displacement, we have to integrate velocity. Now it will work out like this. So A is given. Now we need to find the velocity. So we have to integrate 18 plus 8 dt. So this is going to be 18t square divided by 2. 8t plus, as usual, we know a constant we are getting, that is c. Then we need to give initial condition. So this is 19 square plus 80 plus c. Now 5 is missing. So they will give initial conditions to get this 5. So I will give a condition when t equals 0, c is v is 5. When you substitute this one, you will get c is 5. Now we have the equation v equal v equal 19 square plus 8 4 80 plus 5. This is the, so we integrate this one and we got this one. Now we found out v. Now I need to find out displacement. Then I have to integrate this whatever way I found from here. So this is 19 square plus 80 plus 5. So I want to integrate again. So when I integrate, I will write on top. So I will get 19 square t cube divided by 3. And this is 480 square divided by 2. 5t plus d. Another constant. So now I got s. So I have to give the initial condition when t equals 0, h equals 0. Then from here we will get d equals 0. Then s is going to be 3t square, 9 divided by 3. This is 4t square plus 5t. So basically if the displacement given by differentiating, we can find velocity and the acceleration. If the acceleration is given, if we differentiate one time, we will get the velocity, and when we differentiate velocity, we will get the displacement. Basically, again, if I revise, when we have the acceleration, so we are differentiating to get v equal a dt, and initial condition we have to give when t equals 0, c equal 5. Then I will get v equal 9t square plus 8t plus 5. Then from here I need to get displacement. So S equal v dt. Then with the initial condition, when t equals 0, S equals 0. Then I will get this one. S equal 3t cube plus 4t square plus 5t. It is important that we need the initial condition to find the constant. Discuss example 6. Example 6, it's given that the velocity v equal 6t minus t square. The first question is we need to find this equation expression for the velocity. So S we can get by integrating velocity. So S equal, what is velocity equation? 6t minus t square dt. So this is going to be 6t square divided by 2, t cube divided by 3. So this is going to be 3t square t cube over 3. So when we integrate, we will get plus c constant. We have to add the constant. So now we need to find the constant. Now initial condition is given. Initial conditions. When t equals 0, s equal 5. So when t equals 0, x value is 5. So we can substitute 5 equals 0 minus 0 plus c. So c value is 5. Now we can write the equation is equal 3t square minus t cube over 3 plus 5. Part B, we need to find S value when t equal 6. So then we have to substitute. So S when t equals 6 equal 3 6 square minus 6 cube over 3 plus 5. So this value will give 36 meters. This value is actually, that is 41 meter, and we didn't answer the question yet. So this is the line. Assume this is the origin, it's starting. When t equals 0, the distance is 5 meter. It is here. And when t equals 6, it will give up to here 41 meter. 41 meter. So then from the starting point to this distance is 41 minus 5. So distance from starting point 41 meters 5, that is 36 meter. Further we have to be careful this when t equals 6, the particle is still in the same direction. Sometimes it may change the direction, then we have to work out from there. For example, assume this particle start from, okay, let's say t equals 7. When if you work out t equals 7, we'll find the time. This is in instantaneous rest. So we can find when v equals 0, this is equal 0, 6t minus t square 0. Then t minus 6 minus t equals 0, t equals 0 and t equals 6. So when t equals 0 it is rest, and then t equals 6 it is in rest. And if you want to find t equal, let's say 8, t equal 8, now the particle is in here. Then if you find the distance, it will give this distance only. So hence it is very important that you want to check the instantaneous rest, the place where the instantaneous rest, the time. So when here we found out when t equals 0 and t equals 6, the velocity is 0. So in this place, when t equals 6, velocity is 0. That's fine. Now for this exam calculation is fine. But if t is 8, then it is come to 0 velocity, and it is on the way back. And when you find the displacement from this, it will give the displacement from this origin. Then when you need to find the distance, you have to calculate this one plus this one. So we can find this distance, and then we are not going to find this distance. Instead of what we do, we take whole distance and minus this amount, then we can find this distance. So this is one important thing that we have to check when we find the distance. We need to know that the instantaneous, the velocity is at instantaneous rest. It means the sudden velocity v equals 0. It means sudden rest. When you throw a ball project upward, it will go sudden rest and the ball come down. Let's discuss example 7. The graph is given. So v equal 5 minus 3t square, t greater than or equal to 0. And we need to find the distance. So this is t axis, distance traveled by third second. Third second. So this is a bit of tricky place sometimes. 0, 1, 2, 3, 4. Which one is third second? 2 to 3 or 3 to 4? So this is the third second, not 3 to 4. Sometimes since 3, then after 3 it's not third. So this is the third second, 2 to 3. So we want to integrate, and we want to find 2 to 3 distance traveled. So if the sum is like this without giving any information, first of all, the first thing you need to check the instantaneous rest, where the particle is at instantaneous rest. For that you have to make v equal 0. Then that is 5 minus 3t square equals 0. T square equal 5 divided by 3. T equal plus or minus square root 5 divided by 3. Then t has to be greater than 0. Hence t equal square root 5 over 3. It means this particle, assume if it is travel in a straight line. Yes, it is travel in a straight line, and the particle go up to here. When t equal square root 5 over 3, it is turning from this point. When t equal square root 5 over 3, and so you can see in the graph that then v and t. So the drawn graph is something like this. Now this point, we found out what is this point. This point is square root 5 over 3. So 0 square root 5 over 3. Now 2 to third distance is somewhere here. So 2 to when 2 and 3, that is the third second. This means the particle go stop and somewhere here when t equal to and t equal 3, we want to find this distance. Now we'll work out the displacement. So displacement when we integrate v dt. So this is s equal integrate v mean 5 minus 3t square dt. So when we integrate this one, we will get s equal 5t minus 3t cube plus 3 plus I'll put the constant is alpha. So s equal 5t minus 3 to 3 cancel out, t cube plus alpha. Now we'll find distance when t equal to this distance. S equal 5 times 2 minus 2 cube plus alpha. So this is S equal 10 minus, so this is 10 minus 8. The answer is 2 plus alpha. And when t equal 3, S equal 5 times 3 minus 3 cube plus alpha. So this is going to be minus 12, 27 minus 15 minus 12 plus alpha. It means when t equal 2, so I will adjust this one O. When t equal to, assume that displacement measure from here positive, t equal to the particle is here, and then the t equal 3 particle is here. So then up to this distance is 2. So we are measuring from this point onward positive. Because of that, this is become negative. So this distance is 12. So the total distance is during 2 to 3. This is t equal to, here t equal 3. 14 meters. I will take this when t equal to this distance is s2, this is s3. Then the difference we want to find s3 minus s2. That's how usually the distance traveled by up to 3 minus distance traveled by up to 2 we want to minus. So s3 is minus 12 plus alpha. Then we want to minus 2 plus alpha. So this is minus 12 plus alpha minus 2 minus alpha. So minus alpha minus, so you will get as a minus 14 meter. So this is the total displacement. So distance is 14 meter. So instead of working like that, you can put, you can delete everything, and we can put 2 to 3 this one. 2 to 3. So you don't need alpha then. So this is going to be 5t minus t square divided by 3 is t cube, 2 to 3. So then this is going to be 5, 3 minus 3 cube minus 5, 2 minus 2 cube. So this is going to be minus 12 and minus 2. So we'll get minus 14, minus 14. So the distance is is 14 meter. So from here to here, the direction is same. You can see from up to here, same direction. From here to here, then this circle go, and actually this particle is not taking no other instantaneous, only this place. When we equal to 0, we get one answer. So basically it from here to here it is one direction, and from here to here other direction. So those are the two directions. And yes, that's all basically. We will start the next exercise 11D. One more small thing. Sometimes the particles move starting from here and come back, and that's all. Sometimes the particle is move start from here, come back, and go back. So this kind of motion the particle has. Then origin is O, and if you take this side is the positive to measure displacement, and velocity is positive this side and negative this side. And sometimes you may start to monitor this one from here, t equals 0, not from this place. Sometimes you start the monitor particle from here. So t equal here, s equal minus 5. It means this distance is 5. The starting point, this is the measuring point. So we have to be very careful with these sums when we work out. The most important thing is we need to know the instantaneous rest if we find a distance.